Hello guys, welcome to the journey. Are you looking for selection sort algorithm? This is for you. In this video, we will deep dive into the selection sort algorithm. We'll cover its logic, step-by-step breakdown, real-world applications. Plus, we will implement it in Java and analyze its performance. Let's get into it. Introduction. In this video, we are going to cover one by one. What is selection sort? How does it work step by step? Java implementation of selection sort. We will dry run the code and debug in IntelliJ, time and space complexity analysis, selection sort and other sorting algorithms comparison, and we will come to the real world scenarios where we are going to use the selection sort. What is selection sort? Selection sort is the one of the simplest sorting algorithm. In this algorithm, we will take a unsorted array of integers. From that, we will select a smallest element from the unsorted part. Either it's from the beginning or it's from the ending, and swap it with the first unsorted element so that by the end of this pass, we will place an element at a sorted position. We will repeat this process until the array is sorted. Now, let's get into the step-by-step execution of the algorithm. Here, I am taking unsorted integer array as an example. The array size is 5. Here the array is 64, 25, 12, 22, 11. Here we will do the n minus 1 passes. In the first pass, let's take an unsorted array and find the smallest element from the array. By looking at the example, we can say that 11 is the smallest element and swap with the first unsorted element. Here the first unsorted element is 64. So by end of this pass, we can see that 11 is at the right position. When it comes to the second pass, the unsorted array is of size 4. By observing it, we can easily say that 12 is the smallest element and first unsorted element is 25. So swap 12 and 25. By end of this pass, 11 and 12 are at the right position in the sorted array and 25, 22, 64 in the unsorted array. This is the input for next pass. When it comes to the pass 3, the unsorted portion is 25, 22, 64. By observing it, 22 is the smallest element and the first unsorted element is 25. So swap it. So after this iteration or pass, 11, 12, 22, 25, 64 are at right position. By observing this, the unsorted portion is 25, 64. By observing the previous pass result, we can say that unsorted portion is of size 2. The elements are 25, 64. By looking at, we can say that it's already sorted. But when it go to the logic, we will compare it. We will find the smallest element, that is 25, and compare with the first unsorted element, that is also 25. So no need to swap it. It's already in the order. By end of this all the passes, we can say that the resultant array after sorting is 11, 12, 22, 25, 64. Let's get into coding. Selection sort. We're taking an integer array as input. N is the size of an array. Let's define an outer loop. Looping till n minus 1. Here we are considering first element in the unsorted array as minimum element. Now let's get into the inner loop to find a minimum element in the unsorted array. We are going to check whole array to find a whole unsorted array to find a minimum element. We are comparing with the with minimum element. If it is minimum, we will update the minimum. By end of this iteration, we will find a minimum element from the unsorted array and swap the positions. By end of this iteration, we will place an element into the sorted position. Now let's write a main class to test our algorithm. I am taking a same example what we discussed before so that it is going to be easy to understand. Let's print original array. Now let's call selection sort algorithm. Passing an array as an input, unsorted array as an input. Now let's print sorted array. Let's run this. You can see this after sorting. Now let's analyze selection sort algorithm. This analysis is divided into three cases: best, worst, and average cases. For say, best case is the array is already sorted. Worst case is this complete the array is given in a reverse order. Average case is it's partially sorted or something. When it comes to the time complexity, it doesn't matter. Either the array is sorted, partially sorted, or completely reverse. We need a order of n square as a time complexity because we are going to run every pass we are comparing with another element. That means finding a smallest element from the unsorted array and swapping with by comparing with first element in the unsorted array. So in every pass we need an n iterations. We need an n passes. So n into n, it's an order of n square. When it comes to the space complexity, there is no need of extra space for this algorithm. It sorts in place. When it comes to the stability is very important. By observing the swappings, there is a possibility of disrupt in relative order of equal elements. Now let's get into the comparison of selection sort with other sorting algorithms. For example, bubble sort is another simplest sorting algorithm. If you compare with bubble sort, selection sort performs with a fewer swappings, but still it's required an n square, order of n square time complexity. And when it compares the quick sort and merge sort, these are the quite efficient algorithms. Selection sort is inefficient for the larger datasets, where quick sort and merge sort can perform in order of n log n time complexity. So no need to worry about the selection sort for sorting. Now let's see where we can use and when we can use the selection sort algorithm. Selection sort algorithm performs well for the smaller data sets. If the given input is very small, we can use the selection sort algorithm. When it comes to the memory as a main constraint, if the available memory is very small, so we can use the selection sort algorithm. For example, embedded systems, the available memory is very small, so we can use it there. When it comes to the, for example, you can come up with a challenge like finding a k smallest element from the unsorted array. We can use this algorithm. For say, find a third smallest element from the unsorted array. In the third pass, we can return the third smallest element. If it is a 10th smallest element, in the 10th pass, we can return the 10th smallest element. That's why if someone asks find a kth smallest element from the unsorted array, you can use this sorting algorithm. And for efficiency, break the inner for loop at kth pass. Let's summarize our learning. Selection sort is simple and comparison based algorithm. It is not efficient for the larger data sets. because it takes an order of n square time complexity. But when it comes to the memory, it's an in place, no need of extra space. It's a order of one space complexity. There are some better algorithms like in a quick sort, merge sort, for the larger dataset operations. No need to worry about the if much about the selection sort algorithm. Thank you guys. Happy learning.